Greetings everyone, and well, I'm not at the bench. I'm kind of lost really. I don't know where I'm at. Do you know where I'm at? Leave it in the comments. But anyhow, we're going to talk about speakers today. They're an important link in the audio playback or reproduction. Most important link, in my humble opinion, along with the listening environment. Let's talk about it. Okay, I'm back at home now at the bench. Where's Waldo? Where was I? Leave it in the comments if you know where I was. Kind of make it a little game here. I will say that area I enjoyed walking around it every day I was there. I walked around and put miles on the sneakers. It was a neat little trip. I enjoyed it. But anyhow, back home here, I want to talk about speakers. Mainly concerned with sealed versus ported. What about the other types? You have horns, transmission lines, bandpass boxes. Those would take a pretty long video to discuss. Sealed and ported are the most common, especially ported. So I'm going to stick with those. How do you select a driver for those types of speakers and some of the benefits and drawbacks of each type? First off, we have the sealed speaker. Very simple. It's just a driver in a sealed enclosure. We used to call it acoustic suspension. We've kind of drifted away from that and just call it sealed these days for some reason. What happens is that air becomes part of the speaker's suspension, hence the name acoustic suspension. It kind of acts like a spring and controls the cone. A lot of audiophiles prefer the sound of a sealed speaker. They claim it has tight, accurate bass. And I can agree, that's the type of speaker I've been using in my main listening system for quite a while. The major drawback of a sealed type speaker is it's not going to be as sensitive as a ported speaker for a given size. To get the deeper bass, you need a larger driver, which means the enclosure is going to be larger. You might have heard that you can take a given driver in a ported system and put it in a sealed box that's smaller. Well, that might be true, but number one, you're not going to get as much bass. Number two, that driver may not be idealized for a sealed enclosure anyway. What about ported speakers? With the popular speakers we have today, which are the bookshelf sizes, they're almost always going to be ported because to get the lower bass out of a small enclosure, you have to go that route because, like I say, the sealed's going to need a larger driver. So anyway, a ported speaker is, ignoring the driver for a moment, it's a box of a certain size with a port in it. And that port has a certain length and cross-sectional area, and all those parameters will dictate the resonant frequency of that box. And when you enter the driver parameters into box modeling software, it'll spit out the size of box and the port length and diameter and all that stuff you need. I also included here a passive radiator design, which is quite similar to a ported speaker. But instead of this port, of course, we have the passive radiator. Though it doesn't really show here on my drawing, the actual passive radiator doesn't use nearly as much volume as a port would. If the port is too small, you'll have high velocity air moving through it, and you'll get a lot of turbulence, which creates noise and distortion. To counteract that, you make this port a lot larger, and it starts encroaching on the volume of your box. And to counteract that, you have to make the box larger. So the passive radiator doesn't use nearly as much volume as a proper sized port. Therefore, your box can be a little smaller. I will caution you though, if you go the passive radiator route, is don't cheap out on the passive radiator. it needs to move a lot of air. As a matter of fact, let's say you have a 10-inch woofer driver here. Well, your passive radiator needs to be larger, or at least it has to be a good design that can displace a lot of air by moving quite a bit. In many cases, with a 10-inch driver, people will use a 12-inch passive radiator or 2 8s or 2 10s because a larger surface area needs to move a lot less to move the same amount of air as a smaller surface area. And like I say, the passive radiator needs to move a lot of air, so that's why they tend to be larger than the actual driver. Now, a passive radiator, all it is like a speaker driver without the motor structure. In other words, it doesn't have the magnet or the coil, but it still has the cone and a suspension. And a good quality radiator will have enough linear excursion in its design so it doesn't distort when its cone moves. It'll also have a way to attach or remove weights from it, which changes the moving mass, thus changing its resonant frequency. So just keep that in mind when purchasing a passive radiator, and that's the big drawback of a passive radiator. Good quality ones are expensive, so it might be cheaper just to deal with a slightly larger box and go with the port. Now, these speaker designs are resonant systems. The ported speaker is a fourth order system that rolls off at 24 dB per octave, and the sealed is a second order system that rolls off at 12 dB per octave. And physics will dictate how a resonant system stores and releases energy. And this higher order system has what's known as a higher group delay or a slower response. If you put an impulse signal into a ported speaker and use a microphone and measure the output, you notice there's a bit of a delay because they don't react as fast as a sealed system. That's where people call the sealed speaker more fast and accurate, or whatever they call it. But what do I think of the sound difference? In many cases, provided both speakers are well designed, I don't really notice much of a difference, especially with long sustained bass notes, because of course it's not going to matter as much there. However, with well-recorded kick drums that have a good bass pulse, or music that has sudden pulses of bass, you might notice the tighter, more accurate bass of a sealed system. So, it's really up to you which direction you want to go with your design. Okay, I rambled on long enough about sealed versus ported. Let's talk about how I select the driver for each type. Well, when you select a driver, you want to look at a few things first. Obviously, the size of the driver. If you want big bass, you're going to have a big driver and a big cabinet. It's just the way it works. You're going to have to determine your power. Is it going to be used with a small, lower power amp, or is this going to be a big subwoofer in a car with a big, high-powered amp? What I like to do is determine how much power I'm going to use with the speaker. Let's say I'm going to use it with a 50-watt amp. Well, I might choose a driver that's rated a continuous 100 watts. Why do I do that? That keeps me away from some of its limitations, its compression or distortion. Another parameter I look at is called X-max. That's how much the cone can move. That's not really its limit where, the coil will hit the back of the magnet structure. X-max is more of a linear limit. For example, if the coil moves out of the flux gap of the permanent magnet in the speaker, it'll not be able to move as much, and it'll kind of flat top your waveform. That will lead to distortion and a compressed sound. What value of X-max to choose? Well, that's where you want to look at the software. You want as much X-max as possible, of course, but you'd be surprised, even with a 50-watt amp on a 100-watt driver, especially at lower bass, you might notice it pushing that X-max limit which the software will show you. And another thing, of course, is the speaker's impedance. That depends on the use. And you might 8 or 4 ohms or 2 ohms. Like if you're using the speaker with an older receiver that can only deal with 8 ohm loads, you might want to pick an 8 ohm speaker. Car audio often uses pretty low impedance speakers these days. You get those things out of the way, then I look at a couple parameters. One is free air resonance, and the other is QTS. QTS is kind of a mathematical combination of the QES, the electrical cue, and the QMS, the mechanical cue of the driver. And I use those two figures to determine, kind of pre-qualify as I call it here, if the speaker is going to work better for a sealed or a ported enclosure. Of course, all those other parameters you'll enter into the software and it'll graph how the speaker actually will work. But like I say, this is kind of pre-qualifying. So with a sealed enclosure, I look at the free air resonance figure first. I want to choose a driver that has as low free air resonance as possible. Now for a given size, you'll see that drivers can range quite a bit in its free air resonance. For example, a 10-inch woofer might have a low of 25 hertz, and then you'll see another one that'll be 40 hertz. So if you're going with a sealed alignment, you want to go with a lower value. And that's where sealed speakers tend to need a larger driver, because to get a lower free air resonance, you got to have a larger driver. For example, some 15-inch drivers I see have a free air resonance of below 20. When you put that driver in the sealed enclosure, that trapped air, in other words, that air spring is going to raise the resonance of the system. So that driver with a free air resonance of, say, 25, when it's in a properly sized enclosure, it might jump up to 45 or 50 hertz. Now there's something I should mention called QTC, and that's the damping factor of the sealed enclosure. The value for a critical damped enclosure is 0.7. And by default, most box modeling software will use 0.7 when determining the box size you're going to need. So I just mentioned that to keep that in mind. Sometimes you might find you end up with a box too big. Well, you can squeeze the box size down, usually keeping this value under 0.8, and still end up with a pretty good sealed system. And we'll look at that when I get on the software here in a moment and look at a sealed speaker design. As far as QTS goes, not a real critical value, around 0.4. It can vary up to, say, 0.5. I tend to stay away from speakers that are higher than that. Avoid speakers that are like 1 or 0.7. It's going to require a very large box. There's another way of determining whether a driver can fit in a sealed or ported enclosure called efficiency bandwidth product. I don't use that method. In a way, I think it's kind of misleading to somebody new at designing speakers. It might lead you to believe that a cheap driver might work in a sealed system, because it's not really limiting the QTS value you should select. Okay, so now let's say I'm looking for a driver for a ported system. Well, I reverse the priorities of these two figures here. First, I look at the QTS. I want a driver that's around 0.3. Try to stay below 0.4. Again, your cheapy drivers are going to be higher. They're not going to work that well. But there are really decent, good priced drivers that will work well. They're not going to break the bank. Secondly, is free air resonance. Not as critical as with sealed. I'm just saying here, it doesn't have to go as low. Okay, here's an example. Let's say I want to design a subwoofer. I want a 4 ohm driver, a 10-inch driver. So I look around on Parts Express and I come up with this thing, this GRS 10SW-4HE10. I like that price, $62. It has a dual magnet. That's nice. So let's looky here. Yeah, it's dual ceramic magnet extended pole piece that allows for more room for the coil in there to move. So let's look at some of its parameters here. So it claims 200 watts, 400 max. So that's plenty of power if I use it with 50 watts. And yeah, FS, that's the first thing I like to look at. That's 25.2 hertz. That's very good for a 10-inch driver. So we're starting out pretty good. The QTS is 0.5. That's a little on the high side, but it's still within my limits. So let's pop these numbers into WinISD software and see what we get. Okay, I've entered the speaker parameters into WinISD. It's a pretty comprehensive software. It's free. This is not a tutorial. I'm just kind of showing my process here. So I get the curve for that speaker, and I like this. It's 3 dB down at 36.6 hertz. That's pretty good for sealed. And if you consider room gain, you know, that's going to help prop it up. I also like to look at the 6 dB down point, and that's around 27 or so. Very good. But there's one problem here. That's a pretty big box for a 10-inch, 2.2 cubic feet. Now I can manipulate that number. Let's try a smaller box. Okay, I set the box now to a much more palatable 1.5 cubic feet. And you can see the QTC number. It was 0.7 before, because like I say, it uses that as a default. Now it's up to 0.77, but it's still under 0.8. I try to stay under 0.8 with the sealed box. And our 3 dB down point is still pretty good. Look at that. It's still at 37. 6 dB down has gone up a bit to 29. But heck, you know, that's still very good. Okay, so now I went to the signal menu here and put in 50 watts. Let's say I'm going to use this with a 50 watt amp max. Maybe I'll make a subwoofer using a TDA 7294 chip. And we're looking at cone excursion here. And we have an X max of 11 millimeters with this speaker, and we're well under that. That tells me we're going to get nice clean bass. Even if we push this thing at, you know, down to 20 hertz or so, you can see no problem there at all. One thing I like to do when selecting a speaker is to choose its power rating double what I'm going to use with the amplifier. Because look what happens. When I set this to 100 watts, now we're pushing up against its limitations here. You know, we had an X max of 11, and you know, pretty much in the range it's going to be used. It's getting close to that limit. Well, if you remember, this speaker had a 200 watt RMS rating. I really don't like the word RMS used with watts, but anyhow, and a 400 max rating. But look what happens here if I put 200 watts in. We've well exceeded its X max rating here. We're going to get into some distortion. So that's one reason I like to choose a speaker's power rating that's about double the amplifier rating I'm going to use it with. One last thing I'll show you is the SPL of this design. You know, with the signal at 50 watts. Let's see how much output I get. So we're getting a little over 101 decibels. This is at 1 meter. So that's very good. And 3 dB down would be a little over 98. Well, to put this in the context, many years ago I built what was called a tapped horn subwoofer. At 1 watt of input, it would produce 99 decibels. You know, it was pretty close to this, just with 1 watt of input power. However, that speaker was huge. It was 6 foot tall, probably a group delay nightmare, but it could make some big bass. But you know, as they say, if it's too loud, you're too old. And I'm not young. I don't really care to share my music with the neighbors. I just want a good sounding speaker or subwoofer, whatever the case may be. So, you know, this is not bad. Getting over 100 dB of decent bass, I'll take that. So there you go, sealed versus ported, how I select the drivers, and a little example there. Appreciate you watching. Catch you on the next video.